Hey, okay, so continue on, Advent of Code. We're going to do day 3 today. So I'm going to continue to do it in literate CoffeeScript, because why not? And let's get started. All right, let's take a look at day 3. More toboggans. Okay, I'm very happy about that. With toboggan login problems resolved. You set off towards the airport. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area only grow on exact integer coordinates in a grid. You make a map. The open squares and the trees you can see, for example. These aren't the only trees though. Due to something you read about once involving arboreal genetics and biome stability, the same pattern repeats to the right many times. Okay, so it's a repeating pattern. You start on the open square in the top left corner and need to reach the bottom, below the bottommost row on your map. The toboggan can only follow a few specific slopes. You opted for a cheaper model that prefers rational numbers. Start by counting all the trees you would encounter for the slope right 3 down 1. From your starting position at the top left, check the position that is right 3 down 1. Then check the position that is right 3 down 1 from there, and so on until you go past the bottom of the map. The locations you check in the above example are marked with, here with O, where there was an open square, and X, where there was a tree. In this example, traversing the map using the slope would cause you to encounter 7 trees, starting at the top left your map and following the slope of right 3 down 1. How many trees would you encounter? Okay, so that's interesting. Right, so you get your map, and your map is different than this, and they just want to know how many trees you encounter. Okay, so right, well, let's make some files, and then we'll talk about how to go about doing this one. All right, new folder. Day 3. Don't get ahead of yourself. And new file 1. Lit coffee. Okay. Day 3, toboggan trajectory. Okay. And then we will. Okay, so it looks like we've got a repeating map. It just goes sort of a bitmap, isn't it? There's a lot of text in this one. Right. All right. This is where we define our functions or classes or whatever. And then we're going to have a test section, and then we're going to have a section where we actually just run the output. So this is generally how that works. Literate CoffeeScript indent 4 for runnable code. Okay. So the first thing we'll want to do is let's copy this map. This is our input. So let's copy this into here. Equals. Oops. There we go. What if you need to do that? I forget. I think triple. Let's find out if it strips the white space. I think it might. Okay, so we're going to need to import log, or I guess we have it imported. I guess we'll do this up here. Can also make that mistake every day 50 times. All right, log input. So let's see if this works. Okay, cool. So it strips the leftmost white space, which is nice. That's what I wanted. Okay, so we've got this input, and basically what we need to do, I think, is we need to determine if a given coordinate is a dot or a tree, like open or tree, basically. That's what we need to figure out. In this example, let's just quickly read this again, not make the same mistake we made last time, where I didn't quite read the problem. Okay, checking the So mark, in this example, you encounter 7 trees. So they want to know how many trees you encounter. Okay, so given right a certain number and down a certain number. Okay, cool. So what is this map? This map is effectively just, it's like a grid of spaces. So this is like, you know, space of offset 0, space of offset 1, 2, 3, etc. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's 11 by whatever, that's weird. Yeah, it's 11. Okay, so it's 11 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's 11 by 11. The 11 grid. Okay. So what does that mean? That means this is space of offset 0, and then this would be space of offset 11. This would be space of offset 22. So if you go over 3 and down 1, I guess that would be down 1, you're actually moving, if this was linear, you'd be moving 11 plus 3, so that would be 14. So a down is worth 11 and a right is worth 1. So that's basically, I think, how I'm going to attack this problem. So basically the grid, and then because it repeats, that's interesting. So it repeats this way, so we can't really, I guess we can't really do that, because that would have it repeating downwards forever, whereas in this case we're repeating rightwards forever. So if we just did an array and looped around the array of all these values, I think what we would end up with is basically input that looked like this, which is not what we have. What we actually have is the opposite. It goes to the right. Okay, so scratch that. I guess we're gonna have to deal with each of these rows independently. So I'm gonna break this into, my thinking is break it into an array of arrays. So we'll have an offset this way. So this will be effectively an array, and then this will be effectively an array, and vice versa. And then as you go right, you'll loop around. And then as you go down, eventually as you go down, you'll hit the end. So, okay, so let's do that. Let's turn this input into an array of arrays. Input dot split. I'm gonna split on a new line. Okay, so let's do this on multiple lines. Input split new line, and then we're going to map each line, and then we're going to do line dot split on nothing, and let's log the output of that. Oh, that's angry. Read property split of undefined. Okay. Well. Oh. There you go. No, like that. Read property split of undefined. Okay, on line 84. Let's try to get less fancy and see if that works. Split map. Yeah, it's just my fancy spacing. Okay, so this gives us an array of arrays. Is there a nicer way of doing this? Maybe we can use like a table or something. Oops. I want to be here. What a table output would look like. It's sideways from what I want, but yeah, it's too bad. Okay, I'll stick with log for now. Okay, so this gives us an array of arrays, and each array is either an open or close. Okay, so I guess what we could do is, instead of just like comparing, dot to octothorpe or hashtag, we could just convert these right now into something a little friendlier, like maybe we'll do the truthiness of whether there's a tree there. So we're going to map those, and we're going to line split that, and then we're going to map those char, and then we're going to say we're going to return whether or not the char is a tree. Okay, so let's see what we got. Okay, so we got false, true, false, false. Okay, cool. So now what we've got is we've got basically a map saying false, false, true, true, whoops, etc. Cool. So we made a truth map of whether or not this is a tree or not. Okay, truth map equals. So we'll take in the input, or I guess we'll call it text. Oops. And that will be text. So log truth map input. Input. Good, same thing. Good. So we got truth map. Neat. Okay, so now what we're gonna have is we're gonna put in two coordinates, and the one is gonna be the right offset, and the other is gonna be the down offset. So I guess the horizontal offset and the vertical offset. And we want to know at that point, is it a hit or not? It's kind of like toboggan battleship. Okay, so given this map, what we're going to need is a function that takes some coordinates and tells you whether or not that map has a true there or not. I guess we'll just look up those coordinates. And I guess, I mean, since this is a multi-dimensional array, I mean, you can really just treat the coordinates as like, I guess what we could do is we could say map equals map input, and we could say map of, this is the right offset. Oh, okay, so we are gonna need a function here because we need to handle this repeating stuff. So as it goes off the right boundary of this guy, we need to wrap back around. So, okay, so is hit equals, or is tree, I guess, would be better. And we'll take x, which is horizontal, and y, which is vertical. And I guess we're going to need to know what the map is as well. Map x, y, and then we can say map. So first is going to be y, because that's the first dimension that we're splitting on, and that's the offset of y. Okay, and then we're going to need to know x, but we need to do the remainder of x mod 11, and then I guess that's basically, is that basically it? That might be it. So is tree. So let's look at up here. They said you would encounter 7 trees. So an offset of 1 and 3. So that's 1, 4. So they say right 3, down 1. So you start at 0, 0, and you add 1. Okay. So let's write some stuff here. Okay, so we start at 0, 0, and then we move to 1, 3, or 1, 4. Is that right? Offset of 1, offset of. So we go, we start, because we start at 0. Start at 0, yeah. 1, 2, 3, yeah, that'd be 1, 3. Okay, and then this would be 2, 6, etc. Okay, so these are going to be our moves. 3, 9. Okay, so let's just start with these and see what we get. So we should have nothing. I guess they don't count the first step, so it's only here. O, X, O. So let's see if we get OXO for these. so let's grab our good friend assert. Import assert. I guess we can put this up at the top here. Sure. So let's, oops. Assert false is, I guess assert not is tree, and then map 1, 3, and then we want to assert is tree and then is not tree. Okay, is tree 2, 6, and then not is tree. And you know what? I'm just gonna move these over. Oh wow, I didn't spell map correctly. There you go. So let's see if this works. Oh, it's not import assert. It's require. All right. So assertion false equals true on line 96. So it did not like this. It didn't assert 2, 6, and then 3, 9. Is that what it is? Okay, so it's not liking 2, and then 1, 2, that's 0, 1, 2, 3, 4, 5, 6. Have I got this wrong? So that should be tree. Okay, so let's put out what that is. So x mod 11. So first of all, let's double check that. Log 6 mod 11. Let's run that. Okay, so that's 6, and let's do 16. That should give us 5. Yeah, okay, so I'm not crazy. That is mod. And what else are we going to do? So this is an offset of 0, 1, 2, and 1, 2, or 0, 1, 2, 3, 4, 5, 6. Okay, well, let's find out what this map is. Log map 2, 6. Okay. Is a true, and I was asserting that this returned true. Oh, no. That's, I've got these backwards. I've got XY. This is YX. Okay, well. You know what? Let's, because they always go. Let's YX. That's going to be more natural for me anyway. Okay, yeah. That makes more sense. Okay, oops. Need the map. Okay, so we've got assert not is tree. And so now what are we asking? We're asking, okay, if we start, let's go a few more to make sure that the wrapping works. So the next one is a hit, a miss. So hit, miss. So let's try this. So hit and miss. And then, so this is going to be 4, 6. So this is going to be 12, 15, 18. Good. Okay, so wrapping seems to be working. That's good. Beautiful. So I guess the question is, how many, oh, that's if they give us the map, how many do we hit? But we need to assert that we encounter 7 trees. So we're going to need a loop that basically tests up to 11 on the y offset. So we'll say 1, 11. So you do it. I forget. Log. Yeah. Does that give us? That includes 1. So we actually want 1 to 11. Okay. Actually, we only want 10 steps. Well, we can just say until it's it's greater than or equal to 11. So while or until. So we could say y equals 0, x equals 0, until x is greater than an offset of 10. We can x plus equals 1, or y plus equals 1. Let's make this mistake. And x plus equals 3. Okay, and then what we can do is we can say, and we're going to need num trees. Trees equals 0. And then we'll say trees plus equals 1 if input. I guess we can just do this. I mean, we can turn this into a function. We'll do that in a second. Okay, so trees plus equals 1 if is tree. Map y, x, and then log trees. So that gives us 2 trees. That's not correct. Until y equals is greater than 10. Let's try that now. Cannot read property 0 of undefined, or okay, where is this? On line 73. So 73, we cannot read 0 of undefined. So until y is greater than 10. Oh, you know what? Yeah, it's going to be greater than or equal to 10. Okay, so 7 trees, right? So what I was doing here is I was testing to see if we passed it, and then I was passing it anyway. So that's not going to work. Okay, so this is fine. This is just a hideous block of like naked logic in the middle of the code, and I'm not a big fan of that. So let's talk about what we're doing. So we are always starting at 0, 0 and no trees. And we are always going until the input, the map, until we go off the edge of the map, basically. And we want to move first because we never look at the first. Thing. Although it wouldn't matter if we looked at the first thing. So what we need to do here is we need to make sure that the size or the depth of the map. We want to make sure that we're not going to move past it. I wonder, because I don't know what the test input is like. So this might be a tree in the test input, which would throw us off, or in the real world input. Anyway, in the real toboggan input. So I'm just going to leave it how it is, and we're going to have to make sure that y minus whatever the offset of y isn't going to be over, or plus rather, plus the offset of y, offset y, whatever that's going to be. We need to make sure that that's not going to be greater than the length of the map, like the map height. Okay, cool. So let's grab this stuff and we'll put it up in a tree here. In the defs section, in the section where code goes. Okay, so we're going to need. So what should we call this? Toboggan. How about toboggan? Let's call it toboggan. Toboggan, and we'll give it a map, and we will give it. So it's always going to start at 0, 0, but we want y offset and x offset. And cool. So we're going to start with y equals 0, x equals 0. There we go. And trees equals 0. There we go. So we're going to just assign all these together. And then, oh yeah, set that equal to something equal. There we go. So this is going to be y plus equals to y offset, and this is going to be x offset. And then let's just set these for now. Okay. And we want to make sure that y plus y offset is greater than or equal to map dot length. So because that would be 11. Okay. Cool. And then instead of logging trees, we're just gonna return trees. So this is gonna be number, I guess not toboggan. This is gonna be like number where trees hit. And then we're gonna pass back trees. Okay, so we will log trees hit for map. And then since we have default values for the others, let's see if this works. 7. Beautiful. Cool. And because this is map, I mean, we can just truth map. I don't like truth map, actually. Let's call this tree map. Tree map. So, I mean, this could be just like that. Okay, so trees hit on the tree map of the input. But let's just leave it. So, whoops, let's leave it like this because we're actually going to pass in the x and the y. We're going to pass in, is it 1 and 3? Cool. So we got this. I guess the next thing is just like, does it work? So we actually want to assert equal. I guess we can just assert 7 is 7. Yeah, okay, beautiful. So let's import the actual puzzle. So input, we're just gonna overwrite input again because I'm a monster. Also, wow, space is really bothering me. Require, let's see if I can do this right today. Input. So we're gonna need an input coffee. Okay, just make this regular coffee script. Module dot sports equals, and let's get our tree map. Plus input. All right. Oh, look at that. The first space is not a tree, so we could have actually done it the other way. But I don't care. Cool. Let's also move this around so it can be the y x map. And the reason why I'm doing that is because then I can say trees hit from 3 map, and map is actually just tree map input. So I can just do that. And so as long as assert still works, so this is yx, and just so we're still doing everything in the right order and we don't screw ourselves up, I'm gonna move map to the end here as well. Okay, so let's see if it still works. No, something broke. Can I read property 1 of undefined? Okay, so is tree, and then is tree map. See if I got all the is trees. Yeah, okay. 90. Okay, so we got 90 and our assertions pass. And so yeah, okay, let's plug in 90 and see what they say about that. 90. That's not the right answer. If you're stuck, okay, make sure you're using the full input data. There are also some general tips on the about page. Okay. 1 minute before trying again. So it's not 90. So what have we done wrong? So we've got this one, trees. So all these assertions passed, and they still want us to do right 3 down 1. And 7 is still correct. So right 3 down 1. Please hit 1, 3, and then remap the input. We're getting our input. That's interesting. So we're getting 90, but 90 is the wrong answer. And I wonder why that is. So this is passing. I guess what we could do is we could make a map of the trees and comb through it to try and find an error. That's going to be a massive pain in the butt, but let's do it. This is where good text editor comes in handy. All right, let's just do the first couple of rows. There we go. All right, thank you, Sublime. Okay, that's our input. So let us also log whether or not it was true here. So, and we're gonna log true. Actually, you know, we can just put it back here. We can just do this calculation again. If then true, else log false. Let's see if that works. Okay, it did. Cool. Wow, that's a lot of output. Okay, so let's grab some of these and oops. Do this. I need to split the screen again. No. Sublime. How do you split the screen? No, I just took a screenshot. No. 2, 2, 2. Just trying all the different keyboard combinations I can remember for splitting the screen. View that option shift 2. There we go. Okay, so the first one is 1 should be over 3. Oh, this is weird. Is that right? So in this first case is not. So that is an offset of 3. So we start here and we say 1, 2, 3, and then that's it. Over here, we start here and we go down 1 and we go 1, 2, 3, and this should be a true, and we're getting a false. I think we're getting a false anyway. Where was it? It was in here. So that's because we're on the wrong file. Yeah, false, true, false. So that's the opposite of what I'm expecting. So 1, and then the next 1, 2, 3. So that would be that guy. And then 1, 1, 2, 3 should be. So these should both be true. And I'm getting false, true. So let's take a look at the code and what are we doing? Okay, so tree set. We start with a y offset of 1 and an x offset of 1. I mean, I'm not like tying these variables together, am I? So this gives me the same thing, false, true, true. Yeah, okay, so it's not that. And we haven't hit this until, so the until seems to work. Y equals y, plus equals y offset, x. And then we're doing the y offset. So this would be 1, and then the x offset Okay, so that would be third offset. Yeah, I don't see why that's not correct. Trees plus equals 1 if is tree. And then we return the number of trees. And in this case, it returns false. Okay. Let's log. Oh, you know what? This is these assertions are also logging. So you know what? Let's comment things out and run it again. Okay, so now this is the actual map of what we're logging. Okay, so let's take a look at our input. So 1, 1, 2, 3. So true. 1, 1, 2, 3. True. Yeah. And then 1, 1, 2, 3. False. Yeah. 1, 1, 2, 3. True. So I feel like number 4 is a problem. Let's double check that. So go 1 down over 3, we get a true. 1 down over 3, true, and then 1 down over 3, false. 1 down over 3 should be true. So yeah, number 4 looks like we're wrong. And let's put some more logging in just to double check our logic. Okay. So if is tree, we're going to log y, x, and then true. Else. So we're going to put in the coordinates as well, so we can debug. False. Okay. Okay, so we start 1, 3, true, 1, 3, true. So this is going to be 4, 12, false. This is where we fell over, right here. Here we go. Oops. There we go. So let's look at 4. So this is an offset. This is an offset of 4. So an offset of 1, 3, 2, 6, 3, 9. So 3, 9. Give us a false. Good. 4, 12. 4, 12 give us a false, which is super weird. Does this mean we're not wrapping correctly? So maybe that's... Oh, you know what it is? Oh, I know what it is. It's this stupid mod 11. We don't want a mod 11. I think we want a mod 10 because it's 0 indexed. So let's... All right, let's put our asserts back and see if we still make sense. All right. Assertion error false equals true, so that's not necessarily correct. So on 11. So that should be an offset of 12. And that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, it should be true. No, that's correct. Because oh my god, right, because okay. Oh, that's so stupid. So we hard-coded 11 when we shouldn't have. How many characters is this? 31. So let's just double check that. 1, 2, 3, 4, 5, 6, 7, 8, 10, 1, 2, 3, 5, 6, 7, 8, 9, 10, 11. Yeah, so 31. So this is 31 wide. So we took great care to to not go or to dynamically adjust the height, but we didn't take any care to dynamically adjust the width, which we care about here. So we actually want map length, and that gives us 169, and all our assertions pass. Okay, so, oops, fun time. Okay, so let's see if this is correct, 169. I'll be willing to bet it probably is. Submit. Yay, that's the right answer. Okay, so, yeah, those are the dangers of hard coding values. And, well, we learned, again, not to hard code the values. Okay. So let's grab these. I'd be willing to bet that we're going to start with a very similar situation next part, because that's what we do. All right, part 2. So let's copy and read part 2. Come on. Hello, keyboard. There you go. Okay. Okay. So let's see what we got. Part 2. So time to check the rest of the slopes. If you need to minimize the probability of sudden arboreal stop, after all. Okay. Determine the number of trees you would encounter if, for each of the following slopes, you start at the top left corner and traverse the map all the way down. So right 3 down 1 is the slope we already checked. Right 5, right 5. Okay. The above example, these slopes would find 2, 3, 4, and 2, 2, 7, 3, 4, and 2 trees, respectively. Multiplied together, these produce the answer 336. Oh, okay. So really, they just want us to run this with different inputs and then multiply the answer together. So, so this input I think is the same. Yeah, so this input is the same, and we've got all these. Okay, trees hit. So this is going to be the same, and then this is trees hit with a slope of 1, 3, and they want us to check these guys. Okay, so we're going to make an array of things to check. So slopes equals, and these are going to be xy's, or I guess they're, yeah. All right, so 1, 3, 5, 7, 1. Here. 7, 1, 3, 5, 7, 1. And what was the other one? 1, 1, 1, 1, 2. Okay. 2. So, and then I guess we can put in so that's going to be the x, the y, and then we can put in the expected just to try. So 2, 7, 3, 4, 2. I don't know if we need to do this actually. It's kind of overkill because we're already doing all these assertions up here. Okay, so these are going to be the slopes. And we are going to want to effectively just run trees hit. So slopes dot map slope, and we need to run this and get the answer for each one. So this is going to be trees hit, and then don't forget that it's xy. So this is going to be yx equals slope. It's going to be yx. Oh, sorry, this is backwards. X, y. Cool. And let's log the output of that to see what we get. So we get 2, 7, 3, 4, 2. And is that what they wanted? 2, 7, 3, 4, and 2. Okay, cool. So we're going to do that, and then we're going to multiply those together. So we need to pass that into a reducer to multiply. So slopes map reduce. And yeah, yesterday I think I screwed up the reduce order. It was memo equals 0 and then val, and then, except in this case, since we're multiplying them together, I think I'm going to start with a memo of 1, and then we're going to say memo equals memo times val. And then let's log that. See if that works. Type error cannot read property map. Why is it not liking this syntax today? Reduce of undefined. It's so annoying. Put that, no. It's for product. Yeah, okay. It's just when I'm calling it like a function. And then we can log product. So 336, and is that what they want us to do? 336? Yeah, okay, cool. So, hey, okay, so we've got these slopes. And they want us to find the product of trees hit. So I guess we can just make a thing up here. Product of trees hit equals, we'll take a map and we'll take some slopes. I guess we'll take some slopes in a map because that's what we do. And cool. All right. So slopes, map, trees hit, reduce. I don't have to set memo to that, do I? I don't think I do. Okay. Product of trees hit. It's kind of trees hit. Slopes map. So, dude, I hate having functions that are like, you know, this does like 3 things in series, because it's sort of like, you know, it takes the slope, it maps over the slopes and generates the trees hit, and then reduces it. Like, I mean, it could be worse, but it bothers me when methods start to get complicated enough that it needs several words to name it. But whatever, let's make sure that it still works. Except we're not logging it. 336. Okay, cool. So we've got our slopes. I guess that you don't really need to redefine them down here because it's the same slopes. Okay, so down here we'll do product of trees hit slopes and then the tree map, the input. So I guess this should be assert. What was that, 337? Let's just log it. Out of 336. Okay. So assert 336 is that, and then we can log that here, and this is just how we generate our map. Okay, so this is the product of how many trees we hit. And let's put it in, see what we get. That's the right answer. Cool, we got another gold star. Return to your advent calendar. Here we go. The next one starts in 9 hours. All right, I will be busy, but I'll be back tomorrow. Cool, so yeah, that's basically it. So what we can do now is we can just take another short tour of what we wrote today and see if it still meets our strict approval. Okay, what do we have here? Just logging. Okay, we're getting log and table. We're not using table anymore. I can pull that out. I like table though. I keep wanting to use it and I forget it exists. Assert requires assert. It's really, really useful for when you have like objects, an array of objects. It's beautiful, so you can kind of spread them out and see what everything is. So we've got this tree map. I mean, this is really just, I mean, this could be more readable if you split it up like that. So you're mapping over that, you're mapping over that, and then, yeah, okay. Cool, and then we've got this isTree function. This is a bit weird. So we're gonna say just x, we just call it width. Width equals that, and x mod width. So let's make sure it still works. It does. Yeah, I don't know. I feel of two minds on this. This is a pretty simple accessor, but it's like you're in the map, and then you're on the first one, and then the length, and it just gets a little long. So I don't know. I like to give it a name. That way, you can tell what we're doing. So trees hit. Again, this is just like personal preference. I think I'm gonna pull this into one initializer line just to reset it. Make sure it still works. It does. What this offset? It's greater than that. And we just increment the trees. Yeah, like yesterday, I did a similar thing yesterday. It seems to be like a common thing where you start a counter and then you add to the counter and then you resolve the counter down here. And you could do something similar by mapping the map. You could do something similar with mapping the map. But I guess not in this case because it's not a single array. I don't know. I feel fine with this, honestly. I'm really not that upset about it. Yesterday's solution, we could have done a map as well, but like I don't always feel like mapping results and then just counting the like filtering them is necessarily more readable than this. Like I see a lot of people that are like, oh, it's a more sophisticated result or a more sophisticated code because you're using map and reduce and all these functions and it's purely functional. But I'm like, I get that, but also I don't feel like it necessarily leads to better readability, especially in this case, because it'd be complicated to turn this into sort of like a multi-dimensional map. But just storing the number in a variable and then returning the variable at the end is perfectly fine. As long as you're sort of like in a function like this, I feel like it gives the next person who reads it, which might be you having forgotten everything about it, a really clear idea of what's going on. It's like, oh, you're initializing a value, you're returning the value, and then you're modifying the value based on conditions in here. This sort of like, it reads really well to me, so I'm happy to keep it as is. Okay, what do we got here? This is the test input, all our assertions, and then down at the bottom, of course, we overwrite input. I know a lot of you are probably freaking out about this right now. It's like, oh, you could have made that a constant. I don't really care for constants. And this is exactly what constants are designed to sort of like help with if you try to define it again. But really, I'm just overriding it. I'm just writing over the variable because I don't care anymore, and I don't want to have to think about what input means anymore. Anyway, so that's fine. Let's go to day 2, and I think we cleaned this up on day 1. We'll clean that up on day 2 as well. Okay, so we're gonna map here, and there we go. And right, this was with equals whatever, and I guess I could make stuff. Let's make sure this still works. I think that was the answer I gave. Yeah, so we've got these slopes down here. I guess slopes as a definition should probably be up here because it's really sort of part of the input. It's like a static part of the input. All right, so it still goes to the same answer. Okay, yeah, I'm pretty happy with how this turned out. Let's fix the spacing a little bit, and let's commit it. All right. So what do we got? Good. Yeah. And the input. And let's just, for sanity's sake, let's oops, I always hit the wrong button there. There you go. Here. It's Option M to part 2. Okay, and so and just check out that looks. Toboggan trajectory. It's gorgeous. So that means that I actually want to. There you go. All right, it's day 3. Cool. Push me into origin. All right. So yeah, I wonder what it would be. We did that thing where we screwed up and weren't dynamically responding to the width of this map. That's really the only big misstep that we made, I think, today, which is fine. I mean, who cares? You make mistakes and you fix them. Cool. Would love to hear from you guys if there's anything that you think I could do better. Because as I said yesterday, I'm very new at this. I don't really know. I don't really know what I'm doing with live streaming code. So if you guys have any suggestions for me, I'm happy to hear. Either you can comment on this video because it's going up to YouTube, or you can hit me up on Toronto.js Slack if you're there. Yeah, be happy to hear from you. So yeah, thanks very much, and see you again tomorrow.